It's that weird time of year again where it's still too cold to run the conditioners, but there's a lot of moisture in the air. Today it was 74 degrees out. In the house right now it is 72, and the humidity is 58%, which is not bad, but by the time I take a shower and thaw out some frozen vegetables on the stove, it's going to be probably close to 75, and that's too high for the building. So we need dehumidifier. I have two of these little Waykar units that I use at this time of year. This whole week is going to be high 60s, low 70s with a lot of rain. So we'll be using the dehumidifiers for the next couple of weeks before we can switch over to the conditioners. I do have a few vintage dehumidifiers that I need to clean up. Maybe I'll get to that this week and then we can switch over to those. But I think these are perfectly good for the time being. These utilize 134A refrigerant with a linear compressor. It's a very, very quiet machine. I quite like these, and a handful of other people have bought them since I did and share a similar opinion. So let's go ahead and plug this one in. Unfortunately it has electronics controls, but at least they're fairly simple. So let's check the filter first. There's a little bit of dust on there, but nothing crazy. I'll just go wipe it off outside right quick. That was much dirtier than it looked. So the filter is clean now. And let's go ahead and power this on. The compressor started up. This is on 30%. I just turn it all the way down because the humidity regulation is very poor on these things. As with most of these dehumidifiers, the humidity sensor is placed way too close to the evaporator, such that as soon as the fan shuts off, the residual moisture from the evaporator will cause the sensor to call for dehumidification again, even though nowhere near enough time has elapsed for the actual room humidity levels to have changed. I can hear the gas starting to go through the system. That's the low speed. And that's the high speed. I use it on low because it's quieter. So we'll come back in a little while and see if this is warm. If the output is warm, then it's probably working just fine. Okay, let's go to the other one. Here's the other one. Plug it into this janky outlet. Actually, both of those outlets are kind of flaky. And this sits here at the end of the hallway, and this will capture a lot of the moisture from the shower room. So, let's check the filter on this one too. Yep, this one's pretty dirty as well. I'm gonna go ahead and clean this filter also. I cleaned the filter. I guess I used these a lot more last year than I thought. Okay, I also went and got the meter so we can see how much power these use. I don't think so that they use very much. This is at 120.2 volts. The unit itself says it's allowed to pull where's the amps? 1.2 amps, and then the capacity rating at 65 degrees at 65% humidity, which is the new standard, is 8.5 pints per day. So this is really a very small machine. And then at 80 degrees 60% relative humidity, which I guess is the old standard, that's 12 pints. And they list measurements higher than that, but that's really kind of irrelevant because that's not realistic. So it actually says the 1.2 amps is at this 65 degrees, 60% relative humidity. So I guess it could go more than that if it was hotter, but I can't imagine it going that much more. So let's go ahead and turn this on now. The fan is 0.15, and with the compressor it's 1.03 to start. It's going to go up a little bit as the head pressure builds. Put this down to 30, and then I put this over the screen because it's too bright at night. Okay, so let that run for a minute and then we'll come back and see what the power draw is. The machines have been running for about 20 minutes now. The humidity has gone down from 58 to 54, so they must be working. The output is a little bit warm, as it should be. Let's see if we can hear any water drip out. No, not yet. Well, I think they're both working, so hopefully these will keep going. This is year number 2 on these things. They seem pretty well built. It's a low pressure refrigerant. I don't see why they shouldn't work for a number of years to come. As far as the power draw information is concerned, it's topping out at 1.15 amps with the fan on low. On high, it goes up to 1.19, which is right around what it's rated for. 128 watts with a power factor of 0.94 with the fan on low, and no change to the power factor. So for just over an amp, between the two units, that's like 2.2 amps. That's not much at all.